So we've been working on finding rate of change, and we've always done it as the change in y over change in x because that's what rate of change is. But we're going to actually nail down a formula that you can use for rate of change. I know some of you love formulas. You like having something you can just plug numbers into. Well, here it is. So first of all, let's talk about some of the terminology around rate of change. So rate of change is what we've been calling it. But another word for rate of change that you probably are familiar with is the word slope. Slope and rate of change are essentially interchangeable terms. And we have used the change in y over change in x as our way to define what slope is. And the formula that we use for this, and we've been doing the formula this whole time, even though we haven't actually written it down, but the formula is y2 minus y1 over x2 minus x1. And those ones and twos are not coefficients. We're not multiplying by those numbers. They're called subscripts. It's a little 2 and a little 1 at the base. And those subscripts exist to help us tell the y's and x's apart. Since we have two y's and two x's in the formula, the number 2 represents the second x or the second y that we have, and the number 1 represents the first x or the first y. So you don't do anything with the ones and twos like multiply or anything like that. It's just to show us the first x and y go here on the end, and the second x and y go here at the beginning. Why is that? Why do we put the second one first and the first one second? Remember, rate of change is we're trying to figure out what it goes up by, so or down by. So if I say something went from 1 to 5, the way you would figure out what it went up by is by doing 5 minus 1 to figure out it went up by 4. So if it goes from 1 to 5, we take the second number and subtract the first number to figure out what it went up by. So that's why the 2 comes first. Okay, so let's see how to use it. This first problem that we have here, the coordinates that we've got are -2, 0, and 1, 5. And the first thing I'm going to do is I'm going to label these x1, y1, and x2, y2. Remember that in a coordinate pair, the x is always the first one. So the -2 is going to be the x, and the 0 is going to be the y. And then I'm going to use a different color just for this first one. The 1 is going to be our x, and the 5 is going to be the y. So which one should be x1 and y1, and which one should be x2 and y2? Well, -2, 0 is the one that we had first in the problem, so we're going to call that one x1 and y1. And the one that came second in the problem, we're going to call x2 and y2. Simple as that. So now we're going to use our formula to find slope. The letter that we use for slope is, of course, m. There are some debates about why letter M is used. My personal favorite for why we use letter M is this slope was originally discovered by a French mathematician named René Descartes. That's why we call our graphing sheet the Cartesian plane after him, René Descartes. And he spoke French, and the French word montar means to climb. So I like the idea that the slope of a line he used M for to climb. That's why we use M instead of like S for slope. But I don't think anybody really knows why it's S. I just like that theory. So here's what we're going to do. On the top, we're going to do the change in y. So we're going to do y2, which was 5, minus y1, which is 0. And then on the bottom, we'll do change in x. x2 is 1. And then our x1 was -2. So it's going to look a little weird because we're subtracting a negative. We got minus a negative, but that's all right. We know how to subtract negatives. So on the top, we've got 5 minus 0, which is 5. And on the bottom, we have 1 minus -2, which is the same thing as 1 plus 2, so 3. 5/3 cannot be reduced or simplified or anything like that, so we're just going to leave it as 5/3. You may be tempted to turn this into a mixed number and say it's 1 and 2/3, and that is an answer that would be technically right, but I'm going to discourage you from doing that. I want you to leave it as an improper fraction. For now, the reason I want you to leave it as an improper fraction is because I said so. But later on, whenever we start graphing using slope, you're going to want it to be an improper fraction. You'll see why when we get to graphing. So for now, just trust me. I will explain later why improper fractions are much better for slope than mixed numbers. Okay, let's take a look at problem B. This is displayed to us a little bit different. Instead of coordinates, it's a table, but we're still going to do it the same way. We've got an XY coordinate pair right here, and we've got a second XY coordinate pair here. So the first column is going to be our X1 and Y1, and the second column is going to be our X2 and Y2. Okay, so here we go. M equals Y2, which was -3, minus Y1, which is 4. And then on the bottom, X2, which is 2, minus X1, which is -3. So again, we got minus a negative. No problem, we can do it. So -3 minus 4 is -7. 2 minus -3 is the same thing as 2 plus 3, which is 5. -7/5 will not reduce or simplify, so that is our slope, -7/5. All right, last one. So we're going to label our first one x1 and y1, and we'll label our second one x2 and y2. Our formula is m equals y2 minus y1 over x2 minus x1. 1 minus -1 is 0. Same thing as -1 plus 1. And 2 minus -3 is 5. And 0 divided by 5 is 0. So this last pair has a slope of 0. And something with a slope of 0 is actually a horizontal line. A 0 slope is a completely flat line. So this is the formula for slope, y2 minus y1 over x2 minus x1. It's a really important formula. And if you're considering getting a math tattoo, the formula for slope should definitely be in your top 5 for consideration. M equals y2 minus y1 over x2 minus x1. It's that important.